asking for less whispering. Okay, so in order to calculate the elasticity, first thing we need to do is get our elasticity of demand formula, right? Which is our percentage change in the quantity demanded divided by the percentage change in the price. And again, we're going to put either absolute values around these things up front, or we're going to put absolute values around the whole thing at the very end. Doesn't really matter which one we do. We always know that this is going to be a negative relationship because why? Because the demand curve is downward sloping. So that's part of the reason why we talk about elasticity of demand in positive numbers, despite the fact that we know that when the price goes down, the quantity is going to go up, right? We know that if the price goes from $3 to $4, the quantity is going to go from 200 to 300. That's just the way that demand works. That's the way that consumers work. So in order to do this, we're going to label a couple of things. We're going to label this our QA, and we're going to label this our PA. We'll label this our QA or QB, and then we'll label this our PB. And we're going to separate these things. Let's do our percentage change and quantity demanded first. So for this, we are not going to use our old methodology, which is so in the times past when we did percentage changes, we did new minus old over old, and then we took the whole thing and we multiplied it by 100, right? We're not going to do that anymore. The reason is because essentially these are bidirectional percentage changes, and so in order to do bidirectional percentage changes, we're going to use what's called the midpoint method, which is our new minus old over old plus new divided by 2. So how does this work in our example? Great question. So our percentage change in the quantity demanded is going to be, so we have to pick one of these to be new and one of these to be old, right? And just because of the fact that it's alphabet and left to right, B comes after A, I'm going to pick A to be old and B to be new. So we're going to take the quantity B, we're going to subtract the quantity A, and then we're going to divide it by the average of quantity A plus quantity B, so the average of quantity A and quantity B is just quantity A plus quantity B times, or divided by 2. And so now we just plug in those values, right? So quantity B is 300 minus quantity A, which is 200. Divide that by quantity A plus quantity B. And again, just for completeness, we will put them in here, but we can tell that that's going to be equal to 500. So this gives us 100 on the top divided by 500 divided by 2 on the bottom, which is going to give us, so the way that we can do this is we can say 100 divided by 1 times 2 over 500, and so then that's going to equal 200 over 500. And anytime we have extra hundreds, we can just cancel out those zeros. And so this simplifies down to 2/5. And when we're doing these percentage change problems, we could go ahead and put this in decimal form. There's nothing stopping us from that, right? 2/5 is equal to 0.4. But sometimes the decimal form is not rational, right? It's 0.33333 or something, so it's easier to just kind of keep it in fractions, keep it in 1/3 or keep it in 2/5 or whatever the case may be. Questions on calculating the percentage change in the quantity demanded using the midpoint method. I guess the last part of it is, I always forget this, this part, right? The fact that it's a percent, right? So it's not just new minus old over new blah, blah, blah. It's times 100. So at the very end of it, I always forget, but you have to times this by 100 in order to get the actual percent, which would be a 40% change. Now, here's the nice thing. If you forget to multiply the quantity demanded by 100 and you forget to multiply the percentage change in the price by 100, it ends up giving you the exact same answer, right? Because this reason, A times 100 divided by B times 100 is going to equal the exact same thing as A over B, right? So if we end up multiplying both the top thing and the bottom thing by 100, we can, if we want to go faster and be more efficient, just not include that 100 and not but if you don't include it in the numerator, you also have to make sure to not include it in the denominator as well. But again, for completeness, we are doing percent changes, so might as well multiply by 100 and give it a percent unit at the end there. Any questions on that? All right, let's go ahead and do percentage change of price. So this is going to be a similar kind of thing where we're going to have the price of B minus the price of A divided by the price of A plus the price of B divided by 2. And so since I wrote so big, we'll go down here. So the price B is going to be 3. Oh, and then absolute value around the whole thing, right? So we'll make sure to keep that in mind. We might just bring that down later. But the first price is going to be 3. Then we're going to subtract from that 4. Then in the denominator, it's going to be 4 plus 3, and then all of that over 2. So this ends up giving me what? -1 in the numerator, and then in the denominator, I end up with 7 over 2. So again, if I wanted to, I could just say this is equal to -1 over 1 times 2 over 7. So this is equal to -2 over 7, which is equal to 0.22222 or something like that. But again, easier to just keep it in the fraction. And this is the reason why I said we have those absolute values, right? We want to make sure to keep those absolute values and evaluate it and just look at it as 2/7, which let me just double check that I have the right thing there. 2 out of 7. I was wrong. It is 0.286. So it's around 0.286. And so then we multiply this by 100, and we end up with 28.6%. And so now, given that we have this piece of information, which is our quantity demanded, given that we have this piece of information, which is our price, we can now go ahead and tie them together for our elasticity. The change in the quantity demanded is 40%. The change in the price is 28.6%. 40 divided by 28.6 is going to give us pretty close to 1.4. Now for an extra get out of jail free card, because I'm pretty sure absolutely none of you read, what is the unit of this elasticity? 5, 4, 3, 2.
Isn't it just units? Or just stays like there's nothing?
Very good. Yes, yes. Tell me your name at the end of class. Yes, it's unitless. Very good. This is unitless. So the reason why is because essentially the units cancel out, right? We had a percentage divided by a percentage, so these percentages cancel themselves out, and elasticity does not have any kind of unit in and of itself. It is just a relationship between the quantity demanded and the price. Questions on calculating elasticity? Once again, I said, like I said before, I'll throw this up on YouTube so that you guys can go through this, but you know, they obviously get more complicated than this. I'm not going to give you a bunch of really complicated ones, but they can get more complicated than this. This is a fairly simple one in terms of straightforward numbers, you know what I mean? So I would definitely check and make sure that like you guys can do this on your own before moving on, you know, if you're studying or something like that, right? This is definitely something that's going to be on your midterm exam that you'll be doing online next week, which we'll talk about later. Questions on elasticity and the calculation?